Imagine trying to solve a puzzle without all the pieces. It's difficult, right? That's what it's like trying to build secure software without threat modeling. Threat modeling is like finding those missing puzzle pieces. It helps us understand the security risks in our software before they become real problems. In simple terms, threat modeling is a process where we identify potential threats to our software. We think like attackers to figure out how they might try to exploit weaknesses. This helps us build stronger and more secure software from the ground up. Threat modeling isn't just about finding vulnerabilities, it's about understanding the bigger picture of security. We look at the entire system, how it interacts with users, and what data it handles. By understanding these aspects, we can build software that is not only secure, but also protects user privacy. Threat modeling is an essential practice for any software development team. It helps us create software that is resilient to attacks, protects user data, and builds trust with our users. In today's digital landscape, security is paramount. Software vulnerabilities can have devastating consequences, leading to data breaches, financial losses, and reputational damage. Threat modeling is crucial because it allows us to address security risks proactively, rather than reactively. By identifying and mitigating threats early in the software development lifecycle, we can significantly reduce the risk of security breaches. This proactive approach saves time, money, and resources in the long run. Imagine trying to fix a leaky roof after it has rained. It's much easier and more cost-effective to fix the roof before the rain starts. Threat modeling also helps us build a security-first culture within our development teams. By involving developers, security professionals, and other stakeholders in the threat modeling process, we foster a shared understanding of security risks and responsibilities. Threat modeling is not just a checkbox on a security checklist. It is an ongoing process that should be integrated into every stage of the software development lifecycle. By embracing threat modeling, we demonstrate our commitment to building secure and trustworthy software. There are various methodologies and frameworks available to guide the threat modeling process. These methodologies provide structured approaches to identify, analyze, and mitigate potential threats. One widely used methodology is STRIDE, developed by Microsoft. STRIDE stands for Spoofing, Tampering, Repudiation, Information Disclosure, Denial of Service, and Elevation of Privilege. It categorizes threats based on these 6 categories, making it easier to identify and address them systematically. Another popular methodology is PASTA, which stands for Process for Attack Simulation and Threat Analysis. PASTA is a risk-centric methodology that aligns business objectives with technical security requirements. It helps organizations prioritize threats based on their potential impact on the business. Other methodologies include DREAD, damage, reproducibility, exploitability, affected users, discoverability, TRIKE, attack trees, and kill chains. Each methodology has its strengths and weaknesses, and the best choice depends on the specific project and organizational context. The threat modeling process. The threat modeling process typically involves several key steps. First, define the scope. Clearly define the system or application being modeled, its boundaries, and its interactions with other systems. This step sets the context for the threat modeling exercise. Next, identify assets. Determine the valuable resources that need protection, such as data, hardware, software, and reputation. Identifying assets helps prioritize security efforts. Then, decompose the application. Break down the system into smaller components to understand its architecture and data flows. Diagrams are helpful in this stage. After that, identify threats. Use a chosen methodology, such as STRIDE, to brainstorm potential threats to each asset. This step involves thinking like an attacker to identify potential vulnerabilities. Following that, analyze threats. Assess the likelihood and impact of each identified threat. Risk assessment matrices can be used for this purpose. Then, mitigate threats. Develop countermeasures to reduce the likelihood or impact of each threat. Examples include authentication, encryption, input validation, and access controls. Next, document findings. Create a threat model document that summarizes the identified threats, their analysis, and the proposed mitigations. Finally, validate and refine. Regularly review and update the threat model as the system evolves or new threats emerge. Threat modeling tools. Several tools are available to support the threat modeling process. These tools provide visual interfaces, automation features, and reporting capabilities to streamline the process. One such tool is the Microsoft Threat Modeling Tool, a free tool that provides a visual interface for creating and analyzing threat models using the STRIDE methodology. It allows users to create data flow diagrams, identify threats, and document mitigations. Another popular tool is OWASP Threat Dragon, an open-source web-based tool that supports various methodologies and allows for collaborative threat modeling. Threat Dragon provides a user-friendly interface for creating threat models, generating reports, and sharing findings with team members. Commercial tools such as Threat Modeler and Irius Risk offer advanced features such as automation, integration with other security tools, and reporting capabilities. These tools can be valuable for organizations with more complex threat modeling needs. If you learned something new, like the video and share your thoughts in comments section, and don't forget to subscribe the channel for more related videos.